We already know how to represent shaded part of a figure as a fraction, right? However, most of the examples that we have seen in the past, so they were pretty straightforward. Today, what we are going to do is we are going to discuss a large number of examples that we can expect in the exam that is slightly complicated from what we have seen. Okay, so if you look at the first question, right, so we have to identify the shaded part of this figure and write it as a fraction. Okay, so if you look into this figure, there are two parts. One is a square, the other is the triangle, which is half of the square, right? So we are dividing this square into two equal halves and then shading one of it. So whenever we write a fraction, we have to identify the denominator and the numerator. Denominator is the total number of parts that make up a whole. Right? Here we have two options to write the denominator. Either we count the total number of squares or we count the total number of triangles. What should we count here is dependent on the parts that are shaded or unshaded. So we just look into the smallest part that is unshaded or shaded. Right? For example, here we have two parts. One, the entire square is shaded. The other part is half of the square or a triangle is shaded. So instead of counting the total square, we'll count the total number of triangles because it is the smallest part. Right? So again, in order to count the triangles, what do we need to do? We just count the squares and double the number because each square is equal to two triangles. So you can count the square 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 plus this 12 is 24. So you have 24 squares. Okay. So if we have 24 squares, we'll have 48 triangles. Okay. Now what we'll do, we'll just count the shaded portion, which is the number of triangles. So since we are counting based on the number of triangles, we'll count the number of triangles that are shaded. So 1, 2, 3. Here we have two triangles. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So this is 16 by 48. And we can even simplify this further because they have some terms in common. So if we know the table of 16, we know that 16 and 48 both are divisible, right, by 16. So 16 divided by 16 gives us 1 and 48 divided by 16 gives us 3. So this is 1 by 3. Okay. We can also go by other approaches if we don't know the table of 16, but it is always recommended to remember the table till 20. If you don't know the table of 16, so first you divide both of them by 2, then again by 2, then again by 2, and then again by 2. So you'll get the same answer. Okay, the only difference is that number of steps that you'll take will be much larger when compared to this one-step approach. Right, another way to solve this is you can also count the total number of squares. So 1, 2, 3, 4, 5, 6. So 24 squares you have in total. Now just merge two triangles as a single square. So these two make up a square. These two make up a square. So we have 1, 2, 3, and then 4, 5, 6, 7, and then 8. So this is 8 by 24. Again, both of them have 8 as common, so we divide both of them by 8 to simplify this. Again, we get 1 upon 3 as the answer. However, what is the best approach? The best approach is to always count the smallest part. Okay. A similar type of question, again, we see that the triangles are shaded, right? Which is the smallest part which is shaded in this figure. So instead of counting the rectangles, we are going to count the triangles. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, then 15 and then 16 because this is made up of two rectangles. So we have 16 rectangles and each rectangle makes two triangles, right? So in total we have 32 rectangles. Now how many triangles out of this? So in total we have 32 triangles, not rectangles. We had 16 rectangles, so we got 32 triangles. Out of these 32 total triangles, how many triangles are shaded? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 11, 12, 13, 14, 15, 16. So 16 triangles are shaded. Again, both of them are divisible by 16, so we simplify this further. So 16 divided by 16 and 32 divided by 16. So 16 divided by 16 is 1 and 32 divided by 16 is 2. So we get half as the answer. Similar type of question. Again, instead of counting the total number of squares, we count the total number of triangles. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 squares, which means 24 triangles. So denominator is 24 because we have total 24 triangles in this figure. What about the numerator? It is 1, 2, 3, 4, 5, 6. So 6 by 24. Again, they have numbers in common or factors in common, so we simplify this. So 6 divided by 6 and 24 divided by 6. So 6 divided by 6 gives us 1, 24 divided by 6 gives us 4. Okay. Next we have this figure. So again, if you notice, we have a larger triangle and a smaller triangle, right? So since the smallest part that is shaded is this smallest triangle, right? So we'll count the number of small triangles in this figure. How do we count this? So we divide each of the large triangle into small triangles like this. Okay, so that's it that we need to do. Now we can count the total number of small triangles. We have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 small triangles. So 8 is the denominator, right? Because 8 represents the total number of parts. Now we have to count the parts that are shaded. So 1, 2, 3, 4. So 4 out of 8 is shaded. Again, they both have something in common. So 4 divided by 4 and 8 divided by 4. So 4 divided by 4 is 1, 8 divided by 4 is 2. Okay, so again, half of this figure is shaded. Okay, so this is a different type of question wherein what we are given is slight portion of this part is shaded and slight portion of another part is shaded in this figure, right? So what we need to do in such questions is, so instead of this part being shaded, if I had shaded this part and kept it unshaded, this would mean the same thing. So this is the same thing as, so if I draw the same triangle again, so if I have this triangle, then I divide it into 3 equal parts like this. Draw a circle around this part. Now, what this figure is doing, it is shading this part of this triangle. So, because all 3 parts are equal, instead of shading this part, I can shade this part and then shade this part. Right? So, these two mean the same thing. Because instead of shading this part, I've shaded this part. Because both of them are equal. Right? If you look at this previous example, or say this one. So, instead of shading this part, right, I could have left it unshaded and I could have shaded this part. It means the same thing because both of them are equal part, right? And it does not change the answer, right? So if you look into this figure, say just a small representation. So this is half. At the same time, this is also half, right? So no matter what part of the figure we shade, until and unless the total number of shaded parts remains the same, it does not change the result, right? So the same concept we apply here. So instead of shading this part, I shaded this part and left it unshaded. So it does not change the result. Now, if you look into this figure, it has simplified this question, right? So now the total number of parts are 1, 2, and then 3. So it has 3 equal parts. Okay. And the number of parts that are shaded is 1. Again, you may be wondering why I'm not written the total number of parts as 6, because when we are writing fraction, we need to count the total number of equal parts, right? So total number of equal parts, if I'm counting this triangle and then again this, so this triangular part is not equal to this circular part, right? So since they are not equal, I cannot count them as equal parts. So what I have done instead, I've removed this circle from consideration. Okay, so I just have 3 triangles and one of it is shaded, right? So this 3 equal part and then 1 shaded part. Similarly, if you look into this figure, we have this part was shaded. So instead of shading this part, I shade this part. and then leave it unshaded, right? Once you are done with that, so you have, this is the first equal part, this is the second equal part, this is the third equal part, and this is the fourth equal part, right? Again, I'm not going to write the total number of equal parts as 8 because this part and this part, they are not equal. And denominator means total number of equal parts that make up a whole. So we have to identify the equal parts, which is 1 for this, 1 for this, 1 for this, and 1 for this. So 4 equal parts, out of which this part is shaded. So 1 by 4. Okay. Similarly, we have this figure. Here you can see what are the total number of equal parts. Okay, so first of all, what we do, instead of shading this part, we shade this part. Instead of shading this part, we shade this part. And instead of shading this part, we shade this part. Right, now we have 3 equal parts that are shaded. And what are the total number of parts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is 10 is the denominator, 3 is the number of shaded parts, which becomes the numerator. Okay. Another similar question. So instead of shading this part, we shade this part. Instead of shading this part, we shade this part. And instead of shading this part, we shade this part. Right? So what are the total number of equal parts now? 1, 2, 3, 4, 5, 6, 7, 8. And total number of parts that are shaded are 1, 2, 3. So 3 by 8 is the answer. Okay. For this question, again the same approach. Instead of shading this, I shade this. Instead of shading this, I shade this. Shading this, I shade this. I don't shade this, but I'll shade this. Right? So I have 1, 2, 3, 4. 4 equal parts are shaded. So 4 is the numerator. What are the total number of parts? So 1, 2, 3, 4, 5, 6, 7, 8. Right? So it is 4 by 8, which becomes, so again they have something in common. So 4 divided by 4 and 8 divided by 4. So 4 divided by 4 is 1 and 8 divided by 4 is 2. Okay. Now if you look into this question, so you'll see that the smallest part that is shaded is this half triangle. Right? So you'll divide each of them into half triangles like this. Right? And then you'll count. So first of all, identify what is the smallest part that is shaded or unshaded. Then only try to solve this. So if you count the denominator now, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 equal parts. And how many parts are shaded out of it? 1, 2, 3, 4, 5. 5 is shaded. So 5 by 12 is the answer. Okay. In this question, so this is a question that is repeated most of the times. And in this question, instead of finding this shaded portion, we have to find the unshaded portion. Right? Although it looks complicated, it is pretty simple to identify. So for such type of question, what we need to do is, first of all, we count the total number of rectangles. Right? One thing that you'll notice here is that the smallest part that is shaded is this thing. Right? And we don't know how many such triangles I need to add to make up a complete rectangle. Right? So that approach, the approach that we have been discussing so far, is not going to work. So this is a question wherein irregular portion is shaded. Right? So it is not possible to divide this figure into 2 halves or 4 halves and so on. So for such questions, what we do, say I have to count the fraction of the unshaded portion. Okay. So if you notice this part of this figure, which is unshaded, and this part of this figure, which is unshaded, it makes up a whole rectangle if you combine these two parts. Right? Similarly, if you combine these two parts, it makes up a whole rectangle. Right? So if you combine these two, we get a rectangle. If you combine these two, we get a rectangle. If we combine these two, we also get a rectangle. right? So these two collectively make up one rectangle, right? So this I'm going to eliminate, this I'm going to eliminate, and this also becomes, so these two makes up a rectangle. These two also, if we combine both of them, we get a rectangle, right? So I'll just count this and remove this because we are counting how many whole rectangles we have. So this is half, this is half. So if we combine these two, we get a rectangle, right? If we combine these two, we get a rectangle. If we combine these two, we again get a rectangle. And this two also makes up a rectangle, right? Here also we have a rectangle. Now again we come back to this. So here also these two are half triangles. So if we combine them, we get a rectangle, right? Again we came up with the same thing. So if you have this part and if you look at this part, if we combine both of them, we get a rectangle, right? If we combine both of this, we get another rectangle. Now what we need to do, we just need to count the total number of rectangles, which is the uh, denominator, and the number of rectangles that is unshaded, right? Because we are interested in finding the unshaded portion. Total number of rectangle will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 10 plus 10 is 20. Number of rectangles that are unshaded will be, so 1, 2, 3, then 4, 5, 6, 7, 8, 9, 10, and 11. So 11 out of 20 is unshaded. So if you're interested in finding the shaded part, we don't have to again look back into this. We know 11 out of 20 is shaded, so 9 of unshaded. So 9 out of 20 will be shaded. So the shaded part represents 9 out of 20. Okay. So these are some different cases wherein, so all the cases that we have seen so far, they were proper fractions. Now we are looking into improper fractions, right? So again, there is one confusion that students have is, I'll write 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 8 is 16. 16 plus 8 is 24. 24 is the total parts, right? And 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the number of parts that are shaded. Now this is wrong. Why? This is wrong because, as I have mentioned and repeatedly mentioned the same thing, that denominator, what is the meaning of denominator? Denominator is number of parts that makes up a whole, which means one whole. However, we have calculated number of parts that makes up three wholes. So these are three wholes, right? Three whole figures, right? So when we have to write denominator, we just have to write number of parts that make up one whole. So how many parts make up one whole or one whole rectangle or square, right? Square in this case. So there are 8 parts. And out of that part, now we just look into how many parts are shaded. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of 8 is shaded, right? So this represents 9 by 8. So which basically means if we join all this shaded part, right, it will make up one whole and 1 by 8 fractional part. So this is 1 by 8, right? This means if you join all the shaded portions, you'll get one whole and 1 by 8 fractional part. Because if you just look at this, 1, 2, 3, 4, 5, 6, 7, 8. So 8 shaded part will make up one complete square, so which is one whole, and then you will have this part remaining, which is 1 by 8. So this is the meaning of improper fraction. That is how we have improper or mixed fraction. Similarly, in this question, right, what do we have? Number of parts that make up one whole, which is 3. Right? Because we have 3 parts, 1, 2, 3, 3 triangles. And then we just have to count how many parts are shaded. So 1, 2, 3, then 4, and then 5. So 5 out of 3. So which is 1, 2 by 3. Okay. Similarly, in this question, we have how many parts makes up one whole? 1, 2, 3, 4, 5, 6, 7, 8. So 8 is the denominator. How many parts are shaded? So 8 plus 8 is 16, 17, 18, 19. Because these three are shaded somewhere else, we can shade it here and leave it unshaded. Right, so this is 19 by 8, which is also equal to 2, 3 by 8. So 2 whole parts and 3 upon 8. fractional parts. Right. So in the next series of questions that we'll be solving, we'll look into some numerical statements or some statements given, and we have to find the fraction based on the information given in the statement.